Title: How Engineers Design Two Phaeton Car Lifts for an Open Face-Story Garage. How can you install two phaeton car lifts in an open garage space, with no guide rail walls? At first this may sound like a simple lifting capacity question, but in real parking projects, the lift capacity is only one part of the problem. The more difficult questions are often about structure, pit depth, power supply, platform size, and safety protection. A project in Saudi Arabia shows this clearly. The client had a face-story underground parking garage, with an open, undivided space measuring feet by feet inside the single space. They needed two separate car lifts, each capable of lifting tons. But the site conditions were not standard. There were no existing walls for guide rail mounting. The available pit depth was only and the site power supply was V3 phase. While many heavy-duty hydraulic systems are commonly configured around V power. So the project was not simply about choosing a car lift. It required a site-specific engineering solution. Challenge Phase: No walls for guide rails. The first major challenge was the open garage structure. In many lift installations, walls or a shaft structure can support guide rails and help define the load path. But in this project, the space was open and undivided. That meant a standard wall-mounted system was not suitable. The lift system needed its own structural support. For this reason, EKC engineering team designed a hydraulic post-style car lift with a reinforced self-supporting steel frame. This frame became part of the lifting system itself. Instead of depending on existing walls, the structure was designed to support the guide system, the platform movement, and the load from the vehicles. This is an important point for parking lift projects. When the building does not provide enough structural support, the lift design must solve both the lifting problem and the structural problem. Challenge Phase: Two phaeton platforms in one space. The client did not need one lift. They needed two separate lifts operating side by side. Each lift had to support kg, or tons. At the same time, the platforms needed to be large enough for practical vehicle use. After layout optimization, each platform was designed to measure by feet. This size provides enough room for many standard vehicles and large SUVs. But fitting two large platforms into a feet by feet open space required careful planning. The engineers had to consider platform clearance, structural frame position, vehicle entry, side-by-side operation, and safe separation between lift areas. This is why heavy-duty parking lift design cannot be based only on rated load. The platform size and the garage geometry must be evaluated together. Challenge Phase: The ultra shallow pit. The next constraint was pit depth. A heavy-duty car lift often requires enough space below the platform for structural components and safe movement. But this project had only a feet pit available. That is very shallow for a phaeton lifting system. To match the site condition, the platform base was engineered as an ultra-low-profile structure with an exact thickness of phaeton. The goal was to allow the platform to sit flush with the ground at the lowest level. This matters for vehicle access. If the platform is not flush, vehicles may face entry difficulty, ramp issues, or safety concerns during loading and unloading. A low-profile platform base helped make vehicle entry smoother while staying within the available pit depth. Challenge Phase: Tons on V3. Phase power. The fourth challenge was electrical. Many heavy-duty hydraulic lift systems are normally configured for V power, but the Saudi project site only had V3 phase power available. Instead of requiring a major electrical upgrade, the motor and hydraulic power unit were customized for the actual site power condition. This type of adaptation must be handled carefully. The system still needs to lift heavy vehicles smoothly, maintain stable hydraulic performance, and operate safely under the available electrical supply. So the electrical configuration, motor selection, hydraulic power unit, and control logic all need to be considered as one system. Safety design. Because the lifts operated across a face-story open garage space, safety protection was critical. Automatic roller shutter doors were installed at each level. When the platform moves, the doors close and lock to help prevent people or vehicles from entering an open shaft area. Emergency remote control leveling was also included. If a fault occurs, maintenance personnel can use a dedicated remote control to move the platform safely to the nearest floor. This helps avoid a situation where a vehicle remains trapped between levels. For heavy-duty car lifts, Safety is not only about load capacity, it is also about controlled access, emergency recovery, and predictable operation during abnormal conditions. Conclusion: the Saudi Arabia project shows an important engineering lesson. A heavy-duty car lift project is not only about asking, can it lift phaetons? The better question is, can the structure, pit depth, power supply, platform size, and safety system all work together under the actual site conditions? In this case, the solution required a self-supporting steel frame, 2 phaeton hydraulic post-style platforms, a phaeton ultra-shallow pit design, a phaeton V3, phase power configuration, automatic roller shutter doors, and emergency leveling control. For more details about this Saudi Arabia twin phaeton car lift project, you can read the full case here. https phaeton.com. Phaeton car lift, phase story garage, Saudi phaeton.